All right, geometry students, we want to look at Unit 2, Lesson 7, Angle, Side, Angle, Triangle, Congruence. Two goals here. First is I can explain why angle, side, angle, triangle, congruence theorem works. So if we have an angle, the side next to it, and the other angle that's connected with that side, we can prove congruence with those combinations. I can then use the angle, side, angle, triangle congruence theorem in a proof. So we can use this congruence then to prove some other things or to prove that two triangles are congruent. Our vocabulary, we still have corresponding parts, so the parts that match up and should be congruent. We have auxiliary line. Those are the lines that we can add into the problems to give us a little bit more information, such as on symmetry or perpendiculars or heights, things like that. New word here today is parallelogram, which is a quadrilateral, otherwise known as a four-sided shape, where pairs of opposite sides are parallel. So your opposite sides must be parallel. They cannot be lines that if you extend them, they'll cross at some point. They have to be perfectly parallel to be a parallelogram, and there has to be two pairs of them. All right, so our warm-up that you need to bring tomorrow is a notice and wonder. Remember, try and have two notices and two wonders. The notices are things when you look at it, they kind of jump out at you. The wonders are questions that you have about getting more information. Okay? If you want to kind of deal with this picture a little bit more hands-on, open up the online book, and there's an applet where you can actually drag these lines and try and figure out more to go along with this assertion. So notice here we have two distinct lines, M and L, where QB makes M and PA makes L. QP is actually one point being shared. So here's the assertion. Through two distinct points passes a unique line. So we have 2 points here, 2 points here, two lines. Two lines are said to be distinct if there is at least one point that belongs to one, but not the other. So here we have one point that's shared, that point QP, but A and B are not shared. So these are two distinct lines. Otherwise, we say the lines are the same. If they share more than one point, they would actually be the same line. Lines that have no point in common are said to be parallel. So if they don't share any points, then they're considered to be parallel. Therefore, we can conclude, given two distinct lines, either they are parallel or they have exactly 1 point in common. All right, so based off of the picture and what you see here, and if you want to dive into the online book, come up with two notices and two wonders that will kind of guide our discussion tomorrow. Thanks.